34, they're all on page 201, and we covered all possibilities. I don't see anything else here. All different types of functions. Okay. Of course, this is for me x squared plus 1 to negative 1/2, and this is what should be for you as well. So now f prime. I'm bringing down negative 1/2. I copy x squared plus 1 to negative 1/2 minus 1, which is negative 3/2, and times the inner function prime. Now this is basically a review for Thursday, right? All these differentiations and differentiation rules and products and power rule and the chain rule. So we're reviewing with this. Of course, I will simplify these two. I will have negative x over the square root of x squared plus 1 to the third power. Always remember the denominator is the index and the numerator is the power. If the power is negative, then you bring 1 over. So critical numbers come from two possible sources. When f prime of x is 0, yes, it's a fraction, is 0 only when the top is 0, and this becomes a critical number for sure. And they can also come from f prime being undefined. There is no such thing, because x squared plus 1 is always positive, as requested by the square root, and never 0. X squared plus 1 is always positive. So there are no critical numbers coming from f prime being undefined. Okay, we determine critical numbers for all possible functions that this book, sorry, that's another phone, don't worry about it. Sorry about that. So now let's talk about what is max min. There are two different types. One type is relative, also called local. These are interchangeable. You can say relative max or local max. You can say relative min or local min. Also absolute or global. Global. In some books, you're going to find it as absolute max. In others, you're going to find it as global max, the same thing. So interchangeably, these are the same. Now let's look at the graph. I'm going to graph a function. Here's a function. I'm going to pick some numbers, of course. -4, -1, 6, 10. I'm going to call these points A, B, C, and D. Okay, I'm looking at this function, and this is what I see. And I hope everyone sees the same thing. That obviously, my props, between -4 and -1, between x equals -4 and x equals -1, the function is increasing. Between x equals -1 and x equals 6, very clearly, the function is decreasing. I don't care from which value to which value. I'm just saying for this period of time, if you want, the function is decreasing. And now I'm looking at this piece. Between 6 and 10, the function is increasing. How do we normally write this in algebra? Well, and calculus, we write that f is increasing on the interval -4 to -1, all parentheses, union 6 to 10, and we say that f is decreasing on the interval -1 to 6. So one more time, all x values. We're not looking at the y values. Okay, so obviously, when the function is increasing and then continues to decrease, at this point, the tangent is horizontal. And the next point, when the function is decreasing till this point and then increasing, at this point, then the function has a horizontal tangent, which means that the slope of the tangent is 0. Also, the slope of this tangent, I'm going to put this here at B, so we know, and here at C is also 0. But now we know what that means. It automatically means that f prime of -1, f prime of -1 is 0, as well as f prime of 6 is 0. Okay. One other thing about the graph, and then we're going to write a result. When the function is increasing, here is the tangent. Follow my marker. Tangent, 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 tangent. And then tangent, tangent, tangent. What does this mean? So it also means that x equals -1 and 6 are critical numbers for sure. But it also means that the function, in order to have a maximum, f prime has to go from positive values to 0 or undefined to negative. This is the condition for a maximum. Because I see that this point, B is a local max. For B to be a local max, it is guaranteed that the slope of the tangent, in other words, the derivative, has to be first positive, then it has to be 0, and then negative. Otherwise, this will not be a point of local max. So I'm talking about, these are the signs for f. I used lowercase, f prime of x. These are the signs for f prime of x. Similarly, can anyone give us the signs for a minimum or local minimum? So obviously C is a local min because the derivative changes sign from negative to 0 to positive. 0 may be 0, or because we know, or it can be undefined. So these are the sequence of signs for f prime to guarantee a minimum, a local minimum. So coming back here, when the derivative first is negative, then it's 0, and then it's positive, this is guaranteed to be a local minimum. And what's with the global? So here we talked about local. I need to mention one more thing about local. So we had this graph, and this was B, point B. If I cannot show an open interval, if the function does not exist on both sides, and I cannot show an open interval where all function values are smaller than this one, then that's not a local max. It is a local max because I can show the open interval, the function exists on both sides, and that's the peak, the highest value. So local max or min cannot ever happen or exist at the endpoints of the interval. Of an interval. Never ever. Why? Because I cannot show the open interval. Here I cannot show the open interval. The function exists on this side, but does not exist on this side. So A is not a local minimum, but it's the absolute. Why is it absolute? Because it's the smallest y value possible for this function. D is not a local max because I cannot show the open interval on this side. The function doesn't exist, but it's an absolute max. There is no value higher than it for this function the way I defined it or I presented it in the graph. So I'll have to write that A absolute min, B one more time local max, C local min, and D absolute max. So now I would like to go back to our problems, all of them. We are not ready to graph. I don't even know why they say graph the function. We are still far away from graphing. But now we are ready to identify which critical number changes into a max min and which type. Is it max or is it min? And now I'm ready to go back to old problems that we looked at again. So okay. We started with problem 20. So we continue now with problem 20 again. And I'm on page 9. So back to problem 20, in which we found that x equals 3 was a critical number. We found, I have to copy just the first derivative and the function. Negative 1/3 x to the third plus 3x squared minus 9x plus 2, and f prime of x, which was negative x squared plus 6x minus 9. So the question now is this. Okay, you're happy. You found a critical number. But does this translate into a max min? I don't know. So here's what we're going to use. We're going to use a table. I will not take credit for it. It's not my invention. I wish it were. So x is the variable in the problem. Since this is a polynomial function, x could be anything. I'm really interested in what happens at 3. I know that the derivative is 0 because that's what we determined. The derivative was 0 at x equals 3, not undefined. It was 0. Good. At this point, all I need to determine is 3 of this point, f of 3. So I will determine f of 3 to put it here. And I'll grab my calculator. And I will punch in y equals clear if you have anything else. So I don't understand why this is not working, but it is. So I recommend parentheses around negative 1/3. Negative 1 divided by 3. And then I have x to the third. And then plus 3x squared. And then minus 9x. And then plus 2. I'm checking is correct. Yes. And now I will plug in 3. Plug in 3. And I get negative 7. Fine. At this point, I will study the sign of the first derivative. Study the sign of f prime. No problem. At the same time, I know that this is negative. We looked at it before. X minus 3 squared. So no matter what, this will always be a negative number. Always less than 0. Because this is always positive. It is 0 at 3, but it's always positive because it's squared, or 0. And with minus in front, it will always be negative. So the sign of the derivative is always negative, which means 3 comma negative 7 is not a point of extrema. In other words, not a max or min. How come? Because of this. It doesn't change sign. It's negative, negative, no point of max. It's positive, positive, no point of max or min. It doesn't change sign. It's always negative. You can plug in any number you want. You can plug in 0, you get negative 9. You can plug in 10, I guarantee you get a negative number. It's 10 minus 3, which is 7. 7 squared is 49, minus in front is negative. The derivative doesn't change sign, which means the function is always decreasing. Always. It's not increasing or decreasing. So it doesn't do this. It's not a max, and it doesn't do this, 0, for the tangent. And it doesn't do this. It's not a max, and it's not a min. It's always decreasing. Good. Next function. Any questions? Any questions? That was number 20. Then we looked at 24. Let's analyze 24. Any questions for me, please? Anything? Anyone? Anyone?